Hi everyone, and welcome to the 2020 PyTorch Developer Day. I'm Francisco Massa, and I'm a research engineer at Facebook AI. I work on the PyTorch team, and I'm the maintainer of TorchVision. Today, I'll be talking about what TorchVision is, how it can enable you to get started in computer vision with PyTorch, and the latest additions that have been introduced to TorchVision over the last year. The first question you might ask yourself is, what is TorchVision? TorchVision is a library that is built to facilitate research and experimentation in computer vision. It extends PyTorch with functionality which is very specific and useful to computer vision, so that it keeps the PyTorch library lean and focused on core deep learning abstractions. But what exactly is there in TorchVision? Let's have a closer look. TorchVision facilitates research and experimentation in computer vision by providing a number of building blocks that allows you to quickly start a new project end-to-end. It provides datasets, common datasets for a number of mainstream vision tasks, such as classification and object detection. It also has models. We provide reference pre-trained models for classification, detection, and more. TorchVision also has torch-scriptable operators specific to computer vision models and data transformation operators to simplify creating data augmentation pipelines. Additionally, it contains primitives for efficient image and video reading, and finally, reference training scripts, which illustrates with a few files how you can train yourself the model in TorchVision, leveraging the building blocks that we provide. Over the last year, we have been improving TorchVision in order to simplify the path from research to production. The way PyTorch enables the research to production path is via TorchScript, an intermediate representation of your PyTorch program that can be exportable to run on C++ environments via the TorchScript runtime. The core part of every deep learning pipeline resides on its models. By closely working with the TorchScript and ONNX teams, we have enabled all TorchVision models to natively support TorchScript and ONNX export. Thanks to the pre-trained models in TorchVision, you can quickly build C++ applications leveraging the power of deep learning. But models are only part of the story when it comes to embedding your Python code into a C++ runtime. Very often, you need to prepare the input data into a format that is compatible with the model. TorchVision used to rely on Pillow for most of the data transformations, so moving your application to C++ required re-implementing the transformations in a way which is compatible with C++. Now, TorchVision transforms can directly work on Torch tensors and can be exported to TorchScript, so you only need to implement the transforms once in Python. Finally, TorchVision now provides native I/O functions for image and video decoding, enabling the full raw data to model prediction pipeline to be converted from Python to C++. Now let's get a closer look at each one of those points. All TorchVision models have native TorchScript and ONNX support, so that exporting them to C++ can be done with a couple of lines of code. Additionally, mixed precision training and inference is available for all models, enabling faster runtime with lower memory footprint. TorchVision transforms have been updated to inherit from NN module and accepts Torch tensors as input, with TorchScript compatibility. This brings several benefits to the data augmentation pipeline, such as off-the-shelf GPU support, video use case enablement via efficient batch transformations of frames, and the possibility to export the transforms together with your model in C++ environments. TorchVision now provides image reading and writing operators for JPEG and PNG formats with native TorchScript support. You can directly read local image path into a Torch tensor, or alternatively decompose the operators into raw file reading, where only the bytes of the file are read and returned as the uint8 tensor, and decoding of the raw data into an image tensor. Thanks to native TorchScript support, image decoding can be embedded together with your model for an end-to-end export experience. Finally, TorchVision provides a frame-based video reading API with support for both audio and video, and TorchScript compatibility. The video reader is an iterator and can be combined with iter tools for advanced video reading patterns, such as reading the next 10 frames after a specified timestamp, or skipping every other frame in the video, or reading all frames between 2 timestamps. This new video reader API is currently released as beta, and its API can change following user feedback. We have some additional examples of the new functionalities in TorchVision in the examples folder on GitHub, where you can find notebooks for the video reader API as well as the transforms. In TorchVision, We welcome any contributions. If you find a bug, have a request for an improvement or a new feature inclusion, let us know via the issue tracker on the TorchVision GitHub page, or contribute via pull requests. I'd like to thank you for watching, and I hope that TorchVision can help you build great new applications leveraging PyTorch.